All right, so this video is going to go over the fundamentals of the different types of LLM models, right? Like the words foundational, fine-tuned, chat fine-tuned, pre-trained. All those words are thrown around, and sometimes people use them synonymously, but they all mean different things, and they all have their purposes. Like there's a reason why those stages exist. So this video is going to go over what those different stages are, why they're used, how the models look like, so you have a better understanding of how these LLMs work, especially during the training process. Let's get started. So the first thing is going to be foundational model. And you've probably heard that word thrown around a bit. Foundational model is foundation, right? It's like the foundation with which the whole LLM stack kind of depends on. So when we say foundational model, that typically refers to the architecture, like the number of parameters and like clever techniques that are used, like the attention mechanism. So this is just like introducing the model. It's like kind of premiering, like, wow, we came up with this amazing thing and we want to show it to you guys, but there's not trained on any data, right? Like if you try to use this, it depends on the definition. It kind of goes back and forth, but most of the models, most of the foundational models, they're just pure architecture. So like we have this circle here, which is like an engine. Think of it like an engine of a car, but that's all you get. You don't get a car itself. You just get the pure engine, and you're like, this engine can do some amazing things. I'm not going to build a car for you, but I promise you're going to build something cool out of it. That's what a foundational model is. It's like the architecture and the parameters. From there to actually make use of it, right? Because if you try to use this, you can't, right? Like it's gonna be useless, and sometimes it's kind of trained on some data, like a very little amount of data, but it's still gonna be useless. From there, we go to pre-trained model, and I mean you already know pre-trained. Like GPT has the word pre-trained in it. GPT. The P stands for pre-trained, and like an important thing here is this is still not ChatGPT. Like what you see outputting on ChatGPT is not a pre-trained model, even though it sounds like it is because it's already trained on some data. Like indeed, we are training this on some data at this point. So we have this engine here, like this circle here, that like this research paper came out with, this university came out with, this company came out with, and we want to make use of it. We want to see like what this puppy can do if it's like a car kind of thing. So we take some data, and not some data, typically a lot of data. Like we scrape the web, we take Wikipedia, we take textbooks, videos, whatever it is, and we run that through this model here. Right, so it's the equivalent of taking an engine and dropping it inside like a bare bones car. So it doesn't have AC, it doesn't have, like maybe the windows don't work, maybe it doesn't have windows. We just want to test to see what it can do, kind of thing. That is what a pre-trained model is. So if you actually try to use a pre-trained model, it's still going to be pretty stupid. And the equivalent I can think of for you is if you try to use like pure GPT-2 or pure GPT 3.5 or 4, the way it's going to look like is if you ask it a question, it's just going to kind of answer a question, then ask another question. Then answer that question, then ask another question. It's not going to be smart. Hey guys, real quick, if you're interested in using AI to help your business save time and make more money, my company ApplyGPT helps you do just that. I'm going to put my links down below, and enjoy the video, guys. Like a concrete example of this is if you ask GPT-3, like pure GPT, to be an interviewer, and you ask the question, tell me about yourself, it's just going to answer that question, ask another question, answer that question, ask another. It doesn't know when to stop, right? And like, so the way you can think about this is that at this point, we've put it through so much knowledge, it's very book smart, but it's not street smart. Like it doesn't have any EQ. It doesn't know human interactions, like etiquette, like what is safe, what is not safe. So it's just like a pure bare bones car, like I said before. It's a pure bare bones model that gives some responses. So if you try to use GPT or a pre-trained model, it'll be somewhat smart. It'll be way smarter than this. Like this doesn't really know anything. This does know a lot about a lot. So it'll give you, like if you ask it a question, it'll give you like a half decent answer, but it won't be coherent. Like the language, like the grammar might be off. The idea here, I've kind of driven the point home. From pre-train, we go to fine-tune. And so that's where we're kind of in business. Like that's where you start to see the models that you're using, like ChatGPT or like Llama 3. But notice like there's different versions of Llama, or like if you go on Hugging Face, any model, right? There's like Llama 3 7B, so that's a pre-trained model. And then there's Llama 3 7B chat fine tune, right? The chat fine tune is what this means here. So what fine tuning is really just cleaning up the edges. And let me be more concrete because I don't want to just say fine tune and leave you guys there. So what's actually going on is we already know that LLMs are like these neural networks, right? Like these deep learning models with neurons, which are kind of like numbers, matrices. And what happened in the pre-training process, like so the neurons themselves, that's the foundational model, right? Like they gave us the code, the logic, and the statistical understanding and like theory to build these neurons out. From there we go to pre-trained, which is we have a bunch of data and we run it through this model. What that actually means is in the pre-training data set, there's a question and there's an answer, right? So what we're trying to do, we're trying to auto-correct the right answer. When I say right answer, what's in the data set based on the question. So the pre-training is literally just running this model through the question and the answer, right? So it's gonna run the question through and it's gonna get some response. And it's gonna try to adjust those parameters so that when that question is asked, every single time you get the answer that is in the training data. That is what pre-training is. And I said all that because what fine-tuning is gonna do is, unlike pre-training where we're actually adjusting all the parameters and it's like this big thing here, fine-tune typically is just adjusting anywhere from like 2 to 5% of the parameters. It's small, right? Depending on like if you use QLoRa, and I think there's more now as well, but this is like a 90% of parameters, like 100. It's a big thing. Fine-tune is just 5%, right? And that's actually if you're going if you really want a good fine-tune. So the page just refreshed, so I have to redo the drawing. But all this to say, I'm giving you these parameter counts here to kind of drive the idea in your mind that you don't use fine-tuning to train an LLM on some kind of new data, right? Like you don't use LLM, if there's some new document that's about specific to your company, your domain, you don't use fine-tuning to teach that LLM about that document. And the reason why, because now you know how this thing works, is because we're only adjusting like these little parameters here, right? And like parameters are the way these LLMs learn and are used. So that is why RAG was created, right? Because otherwise, if you don't use RAG, and I have a separate video for RAG, and you have to train more parameters, this is very expensive, right? Because you have to like change those numbers, which means you have to change, like you need big GPUs, and it's not even guaranteed that it's better. So you don't use fine-tuning to kind of train the LM on new data. You use it to kind of roughen up the edges. So what I mean by that is stuff like making sure that it's giving the proper responses and stopping, right? The end of sequence token. So like if I ask a question and I get an answer, I want the LM to just stop there. I don't want it to kind of continue on and on and on into infinity, right? That's an example of building something that's like more chat fine-tuned. Another example is like with safety. So like not answering questions about something that's malicious, right? Like even if the Wikipedia articles in the training data set has that. That's the kind of stuff, and like instead responding with, I can't help you with that. All those kind of things are what's done in the fine-tuning process. So the chat model, right? The chat model is a fine-tuned version of the pre-trained model. So when you see ChatGPT, you're not getting a pre-trained model, you're getting a fine-tuned chat model for that application, right? And then fine-tune can be like for any application really, but most of the time it's chat. Some people will fine-tune their own model for specific applications. For example, if I know that I want to kind of always output in JSON, then I can fine-tune this model so that it's always going to give me the curly braces, open bracket, lower bracket. And keep in mind, like, yes, I'm going to get some JSON in my pre-trained data as well. But to adhere to that format, right, that is why we use fine-tuning here. So like to sum it up, foundational model, it's just a pure engine. There's nothing there. It's just the brains behind it. We put it in a car with the pre-trained model, and now we're feeding it data. So now it works, and it's pretty good, right? So it's book smart, but it's not street smart. It needs to actually like to act like a real human and have like real conversation and like do something useful. You need to fine-tune it to a specific use case. So that's gonna sum it up for this video. Hopefully you guys enjoyed. If you guys have any questions, comment down below, like, subscribe, and thank you guys so much for watching. Bye-bye.